So the quotient property is also going to have a corollary to exponentials. Quotient means divide. If I had something like 2 to the 7th power over 2 cubed, well, that would be the same thing as 2 to the 7 minus 3, or 2 to the 4th power. So note with exponentials, division on the outside became subtraction on the inside. So just like with the product property, logarithms will have a similar idea, it's just the opposite. With logarithms, division inside is going to become subtraction outside. And once again, these properties go both ways. Division inside becomes subtraction outside, or you can go the other way, subtraction outside becomes division inside. So if we have log base b of m divided by n, I can rewrite that as log base b of m. We'll go ahead and let that first one be blue, minus log base b of n, and we'll let that one be red. Again, division on the inside became subtraction on the outside. Let's go ahead and actually put a few of these together. Taking a look at number 7, it's the same two sets of instructions, condense and expand. To condense means to stick together, to turn 2 logs into 1 log. So we're going to have a log base 3, subtraction on the outside, that becomes division on the inside. So 24 minus 8 is going to become 24 divided by 8. Well, 24 divided by 8 is just 3. So this is a log base 3 of 3. That one we can simplify. 3 to the first power is 3. So log base 3 of 3 is just 1. 8 will be another one in which a bit of simplifying is going to help us out here. So note I have log base 2 of 15 minus log base 2 of 15. So what we're really doing here, if we're actually trying to use the property, subtraction outside becomes division inside. So that's the same as a log base 2 of 15 over 15. But 15 over 15, well, anything divided by itself is 1. So what power can I raise 2 to in order to get a 1? Oh, that's just 0. If you're clever, you might have noticed from the outset here, hey, what's anything minus itself? But the idea was to get comfortable with the property. So, like many things in math, there's more than one way to get that final answer. Jumping over to number 9 here, something more aligned with the kind of work we're going to do moving forward. Log base 4 of x to the 9th minus log base 4 of x squared. Well, our base is 4. But now we have those two expressions. Subtraction on the outside becomes division on the inside. So that's an x to the 9th over x squared. In order to simplify that, it's actually back down to this property. So x to the 9th over x squared is actually x to the 7th. So that'll simplify to a log base 4 of x to the 7th. Jumping down, doing a bit of expansion here. Now we have a single log, and we're trying to take that single log and turn it into multiple logs. Keep in mind, there's more than one correct answer for these, but I do want to just walk through the property. So 4 could be the same thing as, say, 16 divided by 4. So I can expand that to being log base 8 of 16 minus log base 8 of 4. Again, that's not the only correct answer. 4 is also the same thing as 4 divided by 1, so we could do log base 8 of 4 minus log base 8 of 1, or log base 8 of 8 minus log base 8 of 2. There are infinitely many correct answers for number 10. So I'm just showing you a couple examples to get comfortable with the idea. On the practice, I'm actually going to tell you which two numbers to use. So that takes away some of the guessing work. With 11, yeah, a bit more clear what numbers we want to use there. We have a 1 divided by 3 on the inside, so division on the inside is the same as subtraction on the outside. Log base 5 of 1 minus log base 5 of 3. Because there's already a fraction inside for number 11, it's more clear how we want to break it up. The practice problems will be a lot more like number 11, where I'll let you know how to break it up. For 12, now in number 12, we actually have a variable. So this is what we'll be using this property for in the future, is actually getting that variable isolated. So that'll be a log. Remember, if there's no base, it's a base 10. So log base 10 of m minus log base 10 of 7. So that's our quotient property. Again, just like the product property, it's similar to exponentials. But again, division inside becomes subtraction outside. It's the opposite of the rule for exponentials. Again, because they're inverses, that's what we expect. So we have our product property, our quotient property. We do have one more property. I'll put that one in a separate video, so I'll see you next time.